Good day, this is the Professor, drwillphd, PhD, and today's Saturday, May 13th, 2023. It is 2:00 and 29 seconds, a.m. Eastern Daylight Time, and today's research, neutron stars. So let's jump to it here. Neutron stars X-rays reveal photon metamorphosis. Date May 4th, 2023. Source, Cornell University. A beautiful effect predicted by quantum electrodynamics can explain the puzzling first observations of polarized X-rays emitted by a magnetar, a neutron star featuring a powerful magnetic field, according to astrophysicists. The extremely dense and hot remnant of a passive star boasting a magnetic field 100 trillion times stronger than Earth's was expected to generate highly polarized X-rays, meaning that the radiation's electromagnetic field did not vibrate randomly, but had a preferred direction. As scientists were surprised when NASA's Imaging X-ray Polarimetry Explorer satellite last year detected that lower and higher energy X-rays were polarized differently, with electromagnetic fields oriented at right angles to each other. The phenomenon can be naturally explained as a result of photon metamorphosis, a transformation of X-ray photons that has been theorized but never directly observed. In this observation of radiation from a faraway celestial object, we see a beautiful effect as a manifestation of intricate quantum electrodynamics is one of the most successful physics theories, but it had not been tested in such strong magnetic field conditions. Quantum electrodynamics, which describes microscopic interactions between electrons and photons, predicts that X-ray photons exit the neutron star's thin atmosphere of hot magnetized gas or plasma. They pass through a phase called vacuum resonance. As photons which have no charge can temporarily convert into pairs of virtual electrons and positrons that are influenced by the magnetar's super strong magnetic field, even in a vacuum, a process called vacuum birefringence. And combined with a related process, plasma birefringence, conditions are created for the polarity of high-energy X-rays to swing 90 degrees relative to low-energy X-rays. You can think about the polarization as two flavors of photons, a photon suddenly converting from one flavor to another. We don't usually see this kind of thing, but it is a natural consequence of the physics if you apply the theory under these extreme conditions. The IXPE mission did not see the polarization swing in observations of another magnetar called 1RXS with an even stronger magnetic field that is consistent with the calculations which suggested vacuum resonance and photon metamorphosis would occur very deep inside such a neutron star. The interpretation of IXPE's observations of the magnetar 4U0142 plus 61 helped constrain its magnetic field and rotation, and suggested that its atmosphere was likely composed of partially ionized heavy elements. Ongoing study of X-rays from some of the universe's most extreme objects, including neutron stars and black holes, enables scientists to probe the behavior of matter in conditions that can't be replicated in laboratories, and adds to understanding of the universe's beauty and diversity. The observations by IXPE have opened a new window for studying the surface environment of neutron stars, and this will lead to new insights into these enigmatic objects. And this is the Professor of Astrophysics, Mathematics, Computer Science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.